Rules for differentiation. Finding the derivative of a product. Now, on your test, that last piece that we did, where we said is, if you have f of x and g of x, if you multiply them together and then take the derivative, is that the same as taking the derivatives and then multiplying them together? We found out that it wasn't. Fine. So how do you do it? Do you have to multiply it out as a polynomial? And then what if you don't have a polynomial? So this is real easy, I promise. You will have no problems with this. Rewrite this function as a cubic function. Multiply it out. Go. Multiply it out. You dang well better not forget. Multiply 2x times everything over there and multiply negative 3 times everything over there.
My mind stopped functioning.
Well, you're...
Well,
my...
As soon as call drops, you don't have to try and So ready.
There we go. So what do we got? 2x cubed minus 7x squared plus 8x minus 3. Hey! You know that's not what I said. So 6x squared minus 14x plus 8. Now that's what we get when we multiply the two functions together and then take the derivative, correct? Now, so the question was on your test, what if I took the derivative of this? What's the derivative of this? 2. What's the derivative of this? So the derivative of each separately is this. This is not equal to this. So the question is, how do you take a derivative when you have things multiplied together? Ladies and gentlemen, if they are polynomials, multiply them out and take the derivative. The question becomes, what if you don't have polynomials? If you look down at the bottom, look at this equation right here. You are multiplying x squared times sine x. That's not a polynomial. How do you take a derivative like that? That's what I'm going to teach you today. If I made you do it by the definition, yes, it would involve limits. I, however, am not requiring you to do it with limits. I'm going to teach you just a nice way. Now, I will do the proof. We will go through a proof, and the proof has to be with limits. But when you actually work them, no, you will not use limits. Proof, not like geometry. No, no, no. You will never do another proof like geometry unless you have to take college level geometry, and you only have to do that if you're a math education major. All right. Here are two of our heroes. Two men, Isaac Newton and Gottfried Leibniz. That's his name, Gottfried Leibniz.
Like, imagine deciding to name your child that. Like, David Jeremiah.
I don't even know what to say. Now, they did not know each other. Yes, I'm sure. Separately, close to the same time, they were developing calculus. But one didn't know the other one was doing it. Now, in 1673, Leibniz published an article in which he derived what we know today as the product rule of differentiation. So what we're going to do, I'm going to write the rule here. I don't think we'll have time to do it today, but next time I'm going to go through the proof with you. The reason I want to go through the proof, if the only math that you need is college algebra or Cal 1, it's not an issue. If you go on past Cal 1, you will see more proving. And I just want you to at least have a little taste of what it looks like. I will never require you to do a proof as a part of a test, all right? The product rule of differentiation says this. If h of x equals, would you shut up? Yes, his name's Godfred. Well, you can. If h of x is equal to f of x times g of x. All right, let's use your brains, not your shoe size. That didn't make sense. Then h prime of x, that didn't make sense. Then h prime of x equals f prime of x times g of x plus g prime of x times f of x. Just write it down.
Wow. But like without like that one. It looks like
Oh, it looks like the cosine of u plus or minus v. Yeah, it looks kind of like that. Now, let me explain how I want you to think this. Notice that f of x was the first, g of x is the second, okay? Derivative of the first times the second plus the derivative of the second times the first. Let me say that again. The derivative of the first times the second plus the derivative of the second times the first. That is the product rule, and that's how you can take the derivative of any product. Now, I'm going to show you how that would work on that problem that we looked at the very top. Now, what I want you to do, erase that, well, mark out that f of x and just put h of x. Now, we're going to call this binomial right here, that's going to be f, and this trinomial here is going to be g. So, h prime of x, the derivative of the first. What's the derivative of the first? Times the second, x squared minus 2x plus 1. The derivative of the first times the second plus the derivative of the second. What's the derivative of the second? Notice I put that in parentheses because that derivative is a binomial, times the first. Clean it up. Look there. Look at there. I would just tell you though, if you have polynomials, I'd tell you to multiply them out and take the derivative and not worry about the product rule. The issue comes is when you don't have polynomials. So this is where we're going. Students often wonder why this rule is so important if we could just rewrite as a polynomial and easily differentiate it. To differentiate means to take the derivative. The answer to that question is simple. If it's possible to rewrite as a polynomial, do it. But in the case of this function here, there's no way to rewrite it as a polynomial. So we're going to apply the product rule. Now notice what it's asking us to do. Use the product rule to find the slope of the normal line at x equal pi. If we want to find the slope of the normal line, what do we need to know? The slope of the tangent line, aka the derivative. Now, I'm going to write this bigger because I'm going to show you something that might help you. Megan Kennedy used to do it all the time. Circle box. Circle box. What she did, she put a circle around her first polynomial and a box around the second polynomial so she could pay attention to what's first and what's second. What are the two things that we are multiplying together here? X squared and sine x. So I'm going to circle one and I'm going to box the other. That way I can remember first and second. Okay. Derivative of the first times the second plus the derivative of the second times the first. There's your derivative. Now I want you to notice, do you notice that I put the x squared in front of cosine x instead of behind it? If you put it behind it, here's what you're going to want to do. You're going to want to say that's cosine of x cubed. It's not. Put trig functions at the end. All right, let's say it together. Say the product rule. H prime of x, the derivative of a product. Derivative of the first times the second plus the derivative of the second times the first. All right. Oh, wait, we didn't finish the problem, did we? All right, fine. Here we go. Shh. We want to find the slope of the normal line when x equal pi. So what do I have to find first? I found the derivative. I need to find the derivative at pi. Yeah, so let's find g prime of pi. Clean it up. What's the sine of pi? Zero. What's the cosine of pi? Negative pi squared. That's the slope of the tangent line. What's the slope of the normal line? 1 over pi squared. Leave that in terms of pi. Do not go to a calculator. Next page. Use the product rule to find the derivatives. We are not going to do this f of x up here. I would tell you to FOIL that out and take the derivative. Now I want you to look at g of x here. I would also tell you to FOIL or multiply that, distribute, and take the derivative. But I want to distribute that with you because I'm afraid you're going to screw it up. Good. You have a little faith. Good. How am I going to distribute? So this is x to the 1/2 times, what is that? No. Why is it 5/2? Because 1/2 plus 2 is 2.5, which is 5/2. It's all right. Life is good. Keep going. 3x to the what? Because 1/2 plus 1 is 1.5, which is 3/2, plus 2x to the 1/2. Now, guys, this is just a rewrite. We have not taken the derivative. I just wanted to make sure you could distribute that x to the 1/2. Let's go on down. F of x equals x cubed times sine x. What are the things we're multiplying together? X cubed and sine x. If you circle box, x cubed and sine x. I can't circle box there because I don't have enough room. All right, f prime of x. Derivative of the first Derivative of the first, 3x squared times the second, plus the derivative of the second times the first. Now, I do have people want to factor out x squareds. Leave it. Unless there's something that you have to do further on, like set it equal to 0, I'd leave that. I wouldn't do anything else to it. Questions? H of x. What things are we multiplying together? 3x plus 2 times cosine x. So circle box, h prime of x. Derivative of the first times the second. Yeah, don't do derivative of the first times the derivative of the second. Derivative of the first times the second plus the derivative of the second times the first. Now, do you notice I didn't write the plus? Why didn't I write the plus? Because the derivative of cosine is minus negative, so I just, instead of putting plus negative, I just put minus. No, don't distribute that sine x. And you have to have, oh, sorry, that's a plus 2 right there. You have to put that 3x plus 2 in parentheses, because if you don't, what's multiplied by the sine x? Just the 2, but the 3x plus 2 is multiplied by sine x. Okay, this one's going to give you trouble. It shouldn't, but it does. Do you notice? Well, number one trouble is it's got x's here and theta's here. Let's do it like this. Let's rewrite it as 3x plus x sine x.
Yeah, technically, it's the thing. Is it
Well, I don't know. What's a thing?
equals to 3 theta plus theta?
Right, that's, yeah, that, exactly, that's a mess. Right, that's just a mess. I want you to look at g of x. Monomial, binomial, trinomial. What are we looking at? Is that a monomial, binomial, or trinomial? It's a binomial. 2 terms. What are the 2 terms? 3x and x sine x. Your notes are right there. When you are taking the derivative of a binomial, remember you take the derivative of each term separately and then add them back together. What's the derivative of 3x? 3. So g prime of x is 3 plus, now look at x sine x. I got to use the product rule there, because what things am I multiplying together? X and sine x, yeah. Circle box. I can circle box since I wrote it. I got enough room. Derivative of the first, 1 times the second, plus the derivative of the second times the first. There's your derivative.
That's it.
That's it. Catherine, what you got?
Could you take out x and do it?
Good question. Could we? The answer is yes. So could we have done this? Could we have rewritten g of x as x times 3 plus sine x and done the product rule? Absolutely. We'll get the same answer. Okay, h of x. How many terms? Monomial, binomial, trinomial. What we got? That's a monomial, right? Right. So I can circle box. My circle box is going to have to look like that. H prime of x. Derivative of the first cosine x times the second. Remember, that's where the square goes. Don't put it behind x. Keep going. Plus the derivative of the second times the first. It's almost the big kahuna, isn't it? I want to remind you what this is. You don't have to write this down, but I want you to look. You know from the big kahuna that cosine squared x, let me do it this way, that sine squared x is 1 minus cosine squared x, right? So what if I did this? Ladies and gentlemen, that's cosine of 2x. That's a double angle formula. Oh my gosh, that's a double angle formula that you did last year. What is happening? We did. We did that last year. We didn't do the derivative last year, but you learned this last year. Because that is cosine of x plus x, which is like cosine of u plus v. Oh. We're not taking the.
Taught this. I don't know if I learned it.
Well, you learned it, but you didn't. You memorized it long enough, and then you quit. Is that it? Yeah.
Probably.
Yeah, I know you people. Find the equation of the tangent line to the graph of this when t is pi over 6. How do I find the equation of a tangent line? What do I need to know?
And the point.
I need the sot and the pot. Right.